Hey, I think this is perhaps one of my favorite trig problems of all time.
You know, I think that it is one of your favorite problems of all time because you've told me numerous times. In fact, just a moment ago, you said that you would marry it if you could.
Why would you say
And that
that
you would,
while we were
and
recording
then
the
you
lesson?
you would have pretty trig babies with this problem. So the code word is going to be trig babies.
Wow, this is almost awkward
Almost,
for me
but not
that
quite.
you did that. That's
All right, we in an earlier section we graphed these and basically figured out what A, B, and C were from the graph.
right by looking at the graph.
But now that we have some difference identities, we can find this out using our identities and algebra and
get
trig
an actual exact answer
value,
for this.
yeah.
Now, if you rewind to that lesson and you graph what you get from doing your lining up all your different things, you will discover that your graph is not 100% identical
because your calculator is
because the
actually
calculator
rounding,
it's
right?
creating an error.
Yeah.
However, when you do this bad boy, it should be the exact same.
Right, right. So
Let's dig in.
we have this sinusoid that has a sine and a cosine. Wants us to write it in this form. And basically the way we start working this out is we take what we're trying to write it as and we use the sum and difference identities on it.
Right.
Where this would be, the bx would be u and the c would be v.
So we're going to have bx takes all the u spots, c takes all the v spots. And you leave that a in front because it's a times the sum or difference of the stuff.
So we've got sine of bx and then cosine of c
plus
cosine of bx
plus sine c.
Not
times sine c. Yep.
Okay, now this can be a little tricky. So what we're gonna do, we're still messing with this to basically make it look like this right here.
Right.
So we're just gonna move some stuff around. We're gonna distribute the a.
Right.
My b's look kind of like sixes, but
they are
not
sixes. That's critical to understanding.
Yes. And then I'd like to do one more rearrangement. I would like to move it to where the sine bx and the cosine bx are last.
Okay, that sounds great.
Here, that's going to correspond with this x here.
That's right.
Inside of that.
Okay, that sounds perfect. So let's do it.
So a cosine c sine bx.
Now, here's the cool thing that you probably aren't going to catch right off the bat until you've worked this a couple of times, and you will need to work this one a couple times. The x is the only thing in here that's a variable.
Everything else
A,
is
B,
numbers.
and C will all be numbers. So when we say A cosine C, that is a specific number like 2 or 17 or negative 35. We don't know. We're going to find it. But A cosine C is a specific number.
Right, and so is A sine C. It's actually a specific number.
That is correct.
So because we're trying to write 2 sine x plus 5 cosine x as this, we're going to set these equal. And then look at what things we may be able to match up. So in front of our sine x, we have A cosine C, we have 2, which means that we can say that 2 equals
A cosine C. Yep.
Okay, we're taking what's in front of sine x and what's in front of sine bx, and we're saying those are the same.
Right.
We also really can say then that right here, that's written kind of badly, but it's 1x, and this is bx, which means b equals 1.
There's your first value right there.
We know b is 1 because there's nothing in front of these x's.
How many x's do you see in there?
If it was 2x,
it would be b equals 2.
Right. And then right here, this 5 goes with what's in front of cosine.
C.
So 5 equals A sine C. Now, go ahead.
And notice here in this case also the 5 cosine x, it's 1x, which corresponds with cosine bx.
Again, yeah.
And again, b would be 1. Well, we determined that already, so b's 1 the whole time through.
Yeah. Now, there's a couple different ways we can go about it. The book does something that I don't think is necessarily intuitive. So I like to look at it this way. See what you think, Mr. Hazelwood.
All right.
We can solve this for cosine C by dividing both sides by A.
All right, sounds great.
Okay, so that cosine C equals 2 over A.
Right.
We all know that cosine is adjacent
Over hypotenuse.
hypotenuse.
Okay, yep,
So
I
we
agree
can
with
say,
that.
hey, look at this I'm going to draw the triangle over here where
All
I've
right.
got some space.
Okay, do it. So we'd say
So
A is the
if
hypotenuse
this
in
is
this
our
case.
angle C, then the adjacent side is 2,
Right.
and our hypotenuse is A.
Okay, that looks great so far.
Okay, we can do the same thing with this one. We can divide by A on both sides and get that sine C is 5 over A.
Oh, looky there. So I know that
So-
one leg is 2 and the other leg is 5.
Right, because this is opposite over hypotenuse.
Right, okay.
Okay,
I'm
which
with
means that to find A, because we want A, B, and C,
I can use Pythagorean's theorem.
Pythagorean's theorem.
Aha! Well, that's a little tricky piece of trickiness.
Yes. So that's 4 plus 25, which
It's
is
29,
29. So
yes.
square root of 29.
Hey, I like that.
The way this works is that technically we could have a positive or a negative square root of 29, but we choose to make it positive.
That is correct, yes.
Okay, so we're
Right.
going to choose for this to be positive square root of 29.
Right.
That is what A equals. We've
Right.
got A and B. Now we need C. So what we can do is plug it into either of these formulas.
You get to pick it. That's the
Right
beautiful
here.
thing.
And so that does mean there's actually like 2 answers
Right,
that are acceptable.
right.
Or instead of there, this actually would be better. One of these two.
Oh,
right?
you know what? You're right. Yes, let's go with the cosine C part down there.
equals 2 over the square root of 29. And so to solve for this C, we do the inverse cosine.
Right. And so this is where, as a high school kid, you look at this and you go, oh my gosh, that can't be the answer. I need a number. Ah!
Yeah.
But that's your answer. The arc cosine of 2 over root 29 is what C is. That guy is your answer. Like, that is an okay thing to have.
We've got A, B, and C. We just need to fill it in up here
Yeah.
to what our actual formula is.
Right.
So, well, I used f of x. So, all right, f of x
Equals
equals A,
A, which is
square root of 29.
times,
It's right there.
yep,
Times sine,
the sine
open
of
parentheses,
bx.
B is 1.
Okay, so x plus c. Now c is that whole arc cosine thing, so you have to include that whole guy in your answer. Now, this is one correct answer.
The other correct
The
answer.
other correct answer would have the arc cosine of 5.
No, the arc sine.
The arc sine of 5 over root 29. That's the other way that you could have this. So both of those would be correct.
If we had solved this for
Right.
C, we would have gotten inverse sine of
5 over,
5 over.
yeah, root 29.
Yeah.
Yep. So that's the other one that could be down there where the arc cosine is.
Okay,
Now,
that's a tough one.
that's a tough one, and having worked through this, I will tell you this is one of my favorite problems because it requires you to use all of your different trig knowledge.
And just a BT dubs, when a teacher says something is one of their favorite problems, it usually means that it's guaranteed to be on the test.
So practice this a couple times, and you'll start seeing some habits that you can form,
Yeah.
and some tendencies that occur,
It's
and then
not
you can
always
take
this
those
hard.
same steps.
If you can, for example, remember this right here instead of having to derive it every time, or if you can remember this instead of having to even mess with this stuff up here.
Mm-hmm.
Once you get the hang of it, it's not as bad.
Right, but it does require some practice.
Yes, it does.